Welcome to Learn Programming in Java Collections. Now, some courses are going to be very generic and allow you to use command line, all various IDEs. This course is going to focus primarily 100% on IntelliJ. Hey, we don't have a lot of money, so I'm going to recommend some, I think, the best value books out there for you. If you want to follow along with these books in the course, they will align very well. If you're kind of on a shoestring budget, the PDF version of the Java 5 book from Bruce Eckel, great value for the money. It's basically free. You want to get the hardcover edition, that's on Amazon. You can click on the link there. It'll take you to the Amazon website. Now, in terms of just a Java 8 book, maybe you can get one used. Maybe a friend of yours has one. Bruce Eckel on Java 8, I think the best book out there, just in general, and programming, his style, his wording, it really explains it all well. So if you're kind of like a book person, you want to read some of his chapters, read and watch my course, that's a great way to learn the language. All right, so what are we covering this time? Collections. This is Java 8 and above. It's a comprehensive set of classes and interfaces designed to handle collections of data. This is bread and butter. You got to know this stuff. Use it pretty much every day. So it provides a standard way to manage groups of objects and includes utilities for data manipulation, like sorting, searching, and iterating. Ever since Java 8, the inclusion of functional programming features have made it even more versatile. So there's some core concepts here. One, there are interfaces, and then there are implementations and utility classes. Now, the interfaces, as you might imagine, they define the abstract data types. The implementations exist, and we're going to go over, I think, based on the 80-20 rule, which is you're going to spend 80% of your time on 20% of these interfaces and collections, and that's what we're going to focus on. Right. In addition to the standard stuff that we've had since Java 8, we now have streams. All right, those are some of the enhancements since Java 8. We're going to go over that in a whole separate chapter, but I wanted to bring it up now that the collections are more than just what they used to be. We can also now stream them, and we're going to see how that gets invoked and used in some other chapters, but we will mention it during this chapter. All right, what do you do if you encounter the typeless collections? You may encounter that in some legacy code out there. Java's been around for a while, so you will see some code potentially that doesn't have a type, like just plain old array list. There's an issue with that. It was great for its time, but look what you can do without the compiler letting you know that there is a problem. If I have a plain old array list without the little brackets, and I don't specify the type, which you can still do, okay, even with this version, but I think you get a warning. You just don't want to do this. You can add an apple, an orange. That doesn't make any more sense. And then when you loop through the list of objects, all right, and it has to be an object because there's no type here, and you forcibly cast the O into an apple. When it's an orange, you're going to blow up at runtime. All right, so this is not what we expect. It's not in the language now, but it still may be out there in some old programs, and want to let you know you don't want to do this anymore. And if anything, if you want to be cool in your team, you will provide perhaps a facade design pattern on top of your old legacy code and do provide types. All right, but that's really an advanced topic, but I want to let you know that the typeless versions are still out there, and you may have to encounter them, and you may have to refactor that code. All right, let's get to the more modern code. An array list is an implementation of a list interface. All right, we'll get more details about that, but here's the compile time checking that I want you to focus on. Do this instead. Always add a type. Always add a type. Now, in the later versions of Java, you don't have to put the type inside this little angle bracket anymore because it's redundant, because it's defined here. But the point here is apple, no orange. At compile time, it will tell you this does not work. And that's what we'd like to see. Not at runtime, errors at compile time and saying, whoops, I can't stick an orange in a list of apples. That makes sense. And I won't blow up at runtime because the compiler is telling me, based on this type, I can't shove an orange into a list of apples. Okay, some of you may be asking, well, wait a minute, what about inheritance? Right, and implementing interfaces. can I use, in terms of the types, what if I had, I don't know, a granny apple that extends apple in a list of apples? Can I shove a granny apple in there? Well, of course you can, because a granny apple is an apple, and a list of apples makes sense. You can put a granny apple inside a list of apples. Now you can't do it the other way around, but you can do it this way. All right, let's get to the 80-20 part. Most of my career, and perhaps most of your career, is going to be set around these implementations and these interfaces. There are more, especially if you do multi-threaded programming. But I mean, for most of the work you've been doing, your collections will be either a list, set, or a queue. And if it's not that, it's probably going to be a map with a key. All right. So those are the most popular, the most useful, and the most important collections, if you ask me. A list must hold the elements in the way that they were inserted. A set can't have duplicates, and a queue produces the elements in the order determined by a queuing discipline. Now compare that to the other type of collection that we probably will use a lot is a map. And that's a group of key value objects, pairs, that looks up a value using a key. You're probably used to that in other languages and other implementations. So those are the biggest popular ones. If you know about the array list, that one looks up an object using a number. So it senses association numbers to its objects, while a map looks up an object using another object. Maps are very powerful programming tools. So that's the difference between an array list and a map, and how they look up things. Performance may be a big deal depending on how you do it. But these are the popular collections. Now, you wouldn't have collections without some utilities around them. And here's one of my favorite ones. So how do you create an array list out of just creating some news? Well, the arrays.asList is a utility function. It's a static function that will help you create an array list. So here's one example of some utilities to the rescue. There's many more, but here's one of them to show you that you don't have to do everything by hand. Here's another example of a utility. There's the add all. So you can take the array of apples, turn it into a list, and then add that whole array as a list into the apples. All right. So this is a way to kind of go from an array of apples, use the as list, and then from that you can put it in the add all. So you can convert things as needed between arrays and array list. Okay, let's get into a little more details. Let's talk about the interfaces of the collection framework. List is probably the most important one. You've probably seen array list out there and linked list out there. So let's remember our discussion previously about implementations and interfaces. List is the interface. Okay, that has the contracts that a implementation must adhere to, and you can generally deal with, and you prefer dealing with interfaces and not implementations. All right, that's another big OO concept. We want to keep that in mind. But an array list is an implementation of the list interface, and it excels at randomly accessing elements. It's a little slower when inserting and removing elements in the middle, though. Compare that to a linked list, which provides optimal sequential access. All right, it's very inexpensive with inserts and deletions in the middle of the list. It's a little slower for random access, but it has a larger feature set compared to array list. So kind of make up your mind which one works best for you. You can probably do some very quick prototyping and testing in terms of performance, but you're going to be using these collections, which are implementations of list, probably a lot. All right, what are part of some of the more popular methods from the list interface? Everybody's favorite size, how many are in there? Contains, you're going to give it an object. Does this list contain that object? Is that in the list? Yes, the equals method will have to be implemented, but that's another lesson. You can also remove it the same way. So you can add a Fido and you can remove a dog. All right. So those are some popular methods. A lot more. Check out the Java doc for all the implementations. All right. A quick Google search was going to show you about 10 different ways to iterate over a list. I'll just give you 2 of them. The old way was a while loop. You probably see this in other languages like C or C++. While the size is greater than 0, plus, and do something with that with that object. That's great. For loop is probably something you see more often. But you're instantiating an I less than size I plus. There's an enhanced for loop. We're going to see that in some of the other chapters. There are about 10 different ways to do this. Here's 2 of the rudimentary ones. I'll leave it up to you to go find the other 8. Whatever you feel comfortable with, but looping through a list is probably one of the things you'll do almost on a daily basis. Okay, what's a set? It is a collection, okay, but it doesn't allow duplicates. A set contains only unique elements. If you try to, what happens when you try to add a duplicate? The operation will fail or have no effect. So the set has no defined order, right? The elements in a set are just generally unordered, meaning that the order of iteration is not guaranteed unless you have a specific implementation like a linked hash set. All right, my favorite set is the hash set. It uses a hash table for storage. It allows nulls. Does not maintain insertion order as mentioned before, but very fast. All right, the linked hash set is a subclass of hash set. Remember the hierarchy, all right, inheritance. But it does maintain insertion order. Slightly slower than the hash set because it uses a linked list internally. The other one I don't use that often, but you should be aware of is the tree set. It implements the navigable set interface based on a red-black tree. If that makes sense to you, great. Go ahead and use it. The first 2 are probably the far more popular than the other one. Let's take a look at an example of the set. So I have a set of cards, okay, and I only want to introduce suits in here. So I can do an ace of diamonds, an ace of spades, an ace of clubs, and ace of hearts. So wait a minute. Didn't you say a set is unique? It is. So what's going to happen here? This, when you try to add a duplicate, when you try to add another ace of clubs, this guy, it'll compile, it'll run, but it won't get added. It just gets ignored. So when you do the loop, you won't find any duplicates inside your list. I should say your collection of type set. These are probably your best friends in terms of the collection classes. It's add, remove, contains, size, is empty, and then clear. All right. So now to ensure there's unique elements, when the order of the elements is not critical, like when you don't care what order they're in, use a hash set. When the order or results are required, when you need to know the order of the hash set, of the set, then you're either going to use a tree set or a linked hash set. Okay, we moved away from lists and sets. Probably the equally powerful collection and interfaces here is the map. All right, a map has a key and a value. That value can be another object. All right, routinely it is. For example, in my fruit inventory map, I have an inventory key and then the actual inventory. Inventory key, another apple. Inventory key, a granny apple. All right, now if I get it by a key, guess what? I can get the apple that I inserted up here. Not this apple, it's this apple because of the key. All right, so this is key value pairs. You've seen it in other languages, but this is how Java implements. It defines the key to be a string and unique. This map has 3 items in the fruit inventory, and you can retrieve it by using the key. It's in my case, I defined it as a string. Doesn't have to be always a string. It can be whatever you want it to be. But whatever that type is, that's your key to get objects. So here's a slide to summarize what we just saw in that previous example. Okay, a map is an object that maps keys to values. It's in the Java util package. It's key value pairs. It associates a unique a unique key with a value. Okay, the keys in the map must be unique. If a key is added that already exists, that all values associated with the key is replaced. Okay, you don't get a runtime error, it gets replaced because it figures out it thinks that's what you want to happen. Now, values may be duplicated. And in that previous example, I showed you 2 apples. Those, but the key it can't be duplicated. All right. It's oddly, and you can argue about this. Map is not a subtype of collection; it's its own thing. Okay, and it does not implement the collection interfaces, which leads to some odd method names, and we're kind of stuck with them. But that's not really critical to your use of them. You're going to use them no matter what, and I wouldn't worry too much about what their hierarchy is in the language. Probably the 2 most popular maps, you're going to use a hash map, which uses a hash table for storage, and the linked hash map is mentioned as a subclass, and it maintains the insertion order. Tree map is a little different. It implements a navigable map interface. It maintains the elements in a sorted order based on the natural order or custom comparator, if you give it that. Does not allow null keys, but allows null values. Now, the hash table, it's a synchronized thread safe one. I don't want to talk about it too much. That's more for multi-threaded programming, and that gets a lot more complex. But wanted to mention the hash table and the tree map. Okay, here's our ramifications of map not being part of the collection hierarchy. It's got its own names. Okay, it's put and get and remove and contains key and contains value. Be careful, it's not just contains, it contains key or contains value. So it depends which one you're looking for. You can also get the set of the keys, you can also get all the values, and then you can get a set view of all the key value pairs with entry set. So there are a lot more methods, but these are the most common ones, and the ones you probably will be using most of the times with a map. What are some quick use cases for the map? It's associating unique identifiers, keys with data, such as user ID and names, lookup tables, caching data for quick retrieval, and representing relationships or mapping between entities. This is going to depend on your business rules, but if you have a key value pair, you're probably going to be using a map. All right, I didn't know where to put this one. This is a record class. I know we're talking about collections and we're also talking about maps, but I wanted to bring this up. A record is a class designed to represent immutable data. Okay, it's boilerplate free. A record class, it has fields called components, but the compiler automatically generates the constructor, the getters, equals hash code, and toString. That's kind of neat. That means you don't need some third-party tool to generate it, and you definitely don't have to do it by hand. What does that look like? It kind of looks like a class, but it's not. It's a record. So take a look at the syntax. Public record person, full name and age, and of course you could probably have the rest of the attributes. I just wanted to show you something quick. Here's an order record that has an ID and a description. Okay, there's probably more attributes, but for now, if you have a POJO, a plain old Java object that just has fields, the record is the way to go. Okay, it's immutable. Okay, you can't change it. You can't modify it later. There's no custom superclass. It cannot extend another class. But I don't think that's too much of a problem. And it's generally not suitable for complex classes when you have some more methods or some functionality or some utilities. But if you just got a plain old class that just has some attributes, records are the way to go. All right. So that was kind of the overview of the list, set, and the map. Those are the interfaces. The implementations are the ones that we use all the time. Now, the record class, I wanted to bring it up now because you generally use those things all together. And these collections are your bread and butter. 80% of the work you're going to be doing is in the 20% of these classes, of this framework. And it's been around for a while. Rock solid. Get used to it and just get comfortable with them. And thanks for going through this chapter, collections.
sin pensar.